Thank you. Tiara Slingerland, please address your question to Dr. Dave.
We were told that because there is very little gravity in space, the vertebrae on an astronaut's body separate and they actually get taller. How much taller do you get?
Well, that's a great question, and we just got the answer to that yesterday. We got out our measuring tape and we set it up on the middeck. I have elongated by approximately 1.5 inches or so. Other crew members seem to be somewhere between 1 inch and 1.5 inches. It's pretty cool. I think, if I maintained this height when I got back on the ground, I might actually be able to play basketball reasonably well.
Thank you, Dave. Natasha Boyd, please ask Barbara Morgan your question. We learned about inertia. Is there inertia in space?
Josh is
That's another great question. Everything is, there's no weight up here, but every object still has mass, and because it has mass, they have inertia. So you have to really hold yourself down if you're working with anything bigger than you are, or it's going to move you around. If I were to push off Dave right now, or we were to push off each other, I'd go flying right out of the picture.
She's so dead.
Joshua Roberts, please ask your question to Dr. Dave.
When you go to space, do your bones dissolve or turn to jelly?
Well, that's a great question, and when we go to space, because of the lack of gravity, our bones lose density. It's just like getting older, except on Earth, once you age, your bone density decreases. When we come back from space to Earth, we regain that bone density again. But it turns out if you stay in space a long period of time, that bone density decreases, and then it starts to plateau. It just doesn't just continue all the way down so that you have no bones left. What we really don't know is what would happen if you stayed in 0G for 1.5 years or 2 years. How low would your bone density go? And right now we're developing exercise protocols to prevent bone loss. And a lot of the medications we're using that could be used to prevent bone loss can have an application in preventing osteoporosis or bone loss in the elderly.
Sarah Ingram, please ask Commander Kelly your question. Does time still feel the same in space? Do you feel tired or hungry at the same time as you would on Earth?
Well, we still have what's called a circadian rhythm that regulates when you wake up and when you go to sleep, and we do have to shift that some depending on what our mission objectives are. It's kind of like if you were to travel overseas, for instance, you might be jet lagged a little bit, so we can be affected by sort of like a jet lag in that if we're time shifting. But even though the sun comes up and goes down every 45 minutes, it doesn't feel like a complete day has passed in that time. So you do still have a sense of time. Certainly without the sun, it's kind of hard to know exactly, what time of day it is, so to speak, whether you're getting towards the nighttime of your day or you're more in the afternoon. But if you look on your watch, you can tell. And one of the things that's kind of interesting, we always seem to be continually snacking. I have my Cano snacks here with me and a camera in my pocket and things, but often you find you don't have a full big meal like you would on Earth, but you're continually snacking and having small portions.
floating snacks. I like floating snacks.
Lexi Ilioya, veuillez s'il vous plaît poser votre question à Dave Williams. Combien de temps prend-il pour votre corps de retourner à un état normal après avoir été sur une navette?
Oui, ça c'est une très très bonne question. La réponse, c'est une condition qui change, qui est vraiment pendant la duration de la mission. S'il y a une mission qui dure à peu près 1 semaine ou 2 semaines, ça prend à peu près le même temps pour les changements physiologiques retourner à normal après l'atterrissage. Mais si la mission dure à peu près 6 mois, 7 mois, ça prend beaucoup de temps après l'atterrissage pour les changements retourner à normal.
Josh Bull, please ask Dave Williams your question.
Is there anything in a spacesuit that keeps an astronaut's feet in a downward position?
Well, you know, in space we love to say there is no up and there is no down, but I've learned, for myself anyway, that up is always wherever my head is. And that was very true when I was doing a spacewalk outside on the International Space Station. If I oriented myself in a certain direction, the Earth could be above me, and I'd be looking up at the Earth a couple hundred miles, or I could turn myself around and be looking down at my feet, down at the Earth below me a couple hundred miles.